In this lesson, we're going to learn how to convert from one unit of measurement into another. There are countless different units used to measure all sorts of things, and very often there are multiple different types of units used to measure the same thing. For example, distance might be measured in inches, centimeters, miles, light years, nanometers, or many others. Power might be measured in watts, horsepower, calories per minute, BTUs per hour, or any other unit of energy per unit of time. Different countries, industries, and situations often call for certain units of measurement. So in science and engineering, it's often necessary to convert a quantity from one unit of measurement to another. This table, found on page 3 of your PLTW formula sheet, shows you equivalent values for many commonly used units of measurement. This table will be a big help as we learn to set up conversion factors and convert units later in the lesson. In order to convert from one unit to another, first we need to understand the conversion factor. We start with a quantity measured in a given unit. We multiply that quantity by a conversion factor to convert the quantity to alternate units. The conversion factor is a ratio expressed as a fraction in which the quantity in the numerator is equivalent to the quantity in the denominator. So when creating a conversion factor, the desired units should be placed in the numerator and the given units in the denominator. Setting up the conversion factor this way is an important step in correctly converting the units. Since the value of the numerator is equivalent to the value of the denominator, the value of the conversion factor is 1. As we know, multiplying any number by 1 will equal the original value. So after multiplying by our conversion factor, our answer will be an equivalent value to what we started with, but expressed in different units. If we rewrite the original given units as given units over 1, we can see that the given units will cancel, resulting in an answer in the desired units over 1. We can then write the answer without the 1 in the denominator. To put it simply, if we have a quantity of A that we want to convert into B, we multiply A by a conversion factor with B over A, perform any multiplication or division that remains, and get our answer in B. Canceling unwanted units using conversion factors is similar to multiplication of fractions, in which numbers that factor in both the numerator and the denominator can be canceled. For instance, in this problem, you may cancel the 7s, one in the numerator and one in the denominator, to give a result of 5 over 3. The method of converting units with a conversion factor works between any system of measurement, as long as a conversion factor of equivalent values can be established. When converting between units within the metric system, it helps to understand the prefixes used with metric units, and how these represent orders of magnitude larger or smaller than the base unit. Once we understand this, we can effectively set up conversion factors to change from one metric unit to another. The prefixes can be applied to the units meter for distance, liter for volume, and grams for mass. Notice that the power of 10 is reflected in the equivalencies. For instance, 10 to the first is 10, 10 to the third is 1,000, and 10 to the sixth is 1,000,000. Similarly, 10 to the negative second is equivalent to 1/100th. 10 to the negative third is equivalent to 1,000th. And 10 to the negative sixth is equivalent to 1,000,000th. If you start with the number 1, the power of 10 can be interpreted as moving the decimal point right for positive exponents or left for negative exponents. Conversion factors are based on equivalencies between units. The prefix table given on page 3 of the PLTW engineering formula sheet provides the equivalencies of SI units in terms of powers of 10. So, for example, 1 deciliter is equivalent to 10 to the first liters. 1 nanogram is equivalent to 10 to the negative 9th gram. Conversion factors are created by using these equivalencies in the form of a fraction equal to 1. If we wanted to set up a conversion factor to convert grams into micrograms, we would check the table and find that 1 microgram is equivalent to 10 to the negative 6th grams. So the fraction 1 microgram over 10 to the negative 6th grams is equal to 1. This fraction is the conversion factor that we would need to multiply our original amount of grams by in order to convert it into an equal amount of micrograms. Again, because conversion factors are created using equivalent quantities, the resulting fraction is equal to 1. Since 1 microgram is equivalent to 10 to the negative 6th grams, the fraction 1 microgram over 10 to the negative 6th grams is equal to 1. Let's see another. What is the conversion factor used to convert megameters to meters? The table shows us that the megameter is equal to 10 to the 6th meters. Since we're trying to convert from megameters to meters, we would set up our conversion factor with the given units, in this case megameters, in the denominator, and the desired units, in this case meters, in the numerator. So our conversion factor in this case would be 10 to the 6th, or 1 million meters, over 1 megameter. Again, because 10 to the 6th meters is equivalent to 1 megameter, the conversion factor is equal to 1, and does not change the value of the quantity once converted. To convert among SI units, simply apply a conversion factor using the appropriate power of 10, in which the desired unit is in the numerator and the given unit is in the denominator. The centimeter units will cancel, leaving the result in meters. Note that powers of 10 can be interpreted as the number of places to move the decimal point. In this case, the power of 10 is negative 2. Therefore, the decimal place can be moved 2 places to the left. These rules of exponents will help you manipulate the powers of 10 and make conversions using metric units. 10 to the power of 0 equals 1. So multiplying any number by 10 to the power of 0 will return an equivalent value. When powers of 10 are multiplied together, the exponents are added together. So in the example of 10 to the 5th multiplied by 10 to the negative 2nd, the exponents 5 and negative 2 are added together for an end product of 10 to the 3rd. Similarly, when powers of 10 are divided, the exponent of the denominator is subtracted from the exponent of the numerator. In this example of 10 to the 6th divided by 10 to the negative 1st, the exponent 6 minus the exponent negative 1 results in an answer of 10 to the 7th. To convert among SI units, simply apply conversion factors using the appropriate power of 10, in which the desired unit is in the numerator and the given unit is in the denominator. In this example, we're converting from kilometers into centimeters. So we need to set up 2 conversion factors. The first will convert our given units into the base unit, meters. The second will convert the quantity of meters into the desired unit, centimeters. The first conversion factor is 10 to the 3rd meters over 1 kilometer, a value equal to 1. And the second conversion factor is 1 centimeter over 10 to the negative 2nd meters, another fraction equal to 1. When units that appear in the numerator of one fraction also appear in the denominator of another, these units cancel out, leaving the result in the desired units. Again, powers of 10 can be interpreted as the number of places to move the decimal point. In this case, the power of 10 is 5. Therefore, the decimal place can be moved 5 places to the right, giving the final result of 500 centimeters. The conversion factors are often exact numbers. Therefore, the number of significant figures indicating the precision of the number should not change when you convert to an alternate unit. However, in reality, measurements, unless taken as part of a scientific investigation, are rarely recorded to the appropriate number of significant figures. So it's not uncommon to round converted measurements to a given precision, say to the nearest hundredth of a meter or to the nearest 1/8 of an inch. If the precision of a measurement is critical, you must check that the precision recorded is correct and acceptable for the application for which the measurement will be used. The same concept of unit conversion applies to U.S. customary units. Conversion factors are based on equivalencies. Once you've identified the equivalency involving the given units and the desired units, create a ratio or fraction with the desired units in the numerator and the given units in the denominator. To convert from feet to miles, we would need to know the equivalent value of feet and miles to set up a conversion factor. The table in our formula sheet tells us that there are 5,280 feet in 1 mile, so if miles is the given unit and feet is the desired unit, then our conversion factor should be 5,280 feet over 1 mile. Multiplying any number of miles by this conversion factor would tell us the equivalent value in feet. Again, because the numerator is equivalent to the denominator, the value of all conversion factors is 1. To convert among U.S. customary units, simply apply a conversion factor using appropriate equivalency in which the desired unit is in the numerator and the given unit is in the denominator. The appropriate conversion factor to convert yards into feet is 3 feet over 1 yard. The yards cancel, and you're left with feet. Assume that the conversion factors are exact numbers. Therefore, the number of significant digits indicating the precision of the number should not change when you convert to an alternate unit. In other words, the precision of your answer should be the same as the precision of your given units unless you're told a specific precision to round to. When converting from feet and inches to inches, you must convert the portion of the measurement reported in feet to inches. Now both quantities are expressed in the same units, and you can add them. When converting feet and inches to feet, you must first convert the inch portion of the measurement into feet. Notice that you can find the decimal equivalent of 7 3/4 by adding 7 and 3 divided by 4. Once both quantities are in the same unit, you can add them together to get your final result in feet. The same concept of unit conversion applies when converting between the US and SI systems. Use equivalencies to create conversion factors with the appropriate numerator and denominator. Some of the common equivalencies between the US and SI systems are provided on the PLTW formula sheet. Let's look at a conversion factor for changing inches into centimeters. The desired unit is placed in the numerator, and the given unit is placed in the denominator. Like all conversion factors, the value of the fraction is 1. Let's practice converting from standard to metric units using the conversion factor we just found. Start with the given quantity. Then determine the appropriate conversion factor. Cancel the given units, which are repeated in the numerator and denominator. Perform the multiplication to obtain the result. Note that the number of significant digits in the original measurement was 3. Therefore, the number of significant digits reported in the result is also 3. Let's see another example, but this time we'll convert between units of mass. Begin with the given quantity and find an equivalency, or a series of equivalencies, that relates the given unit to the desired unit. In this case, the equivalency is given in your formula sheet. Write the conversion factor so that the given units cancel and the desired units remain. Calculate the result and consider the number of significant digits. In this case, the original quantity has 2 significant figures, so we will round the final answer to 2 significant digits, which seems reasonable. For DDE, the required precision of an answer may be directly stated in the problem. If not, use a reasonable precision based on the provided information and the use of the result. If you do not have an equivalency between the given units and the desired units, you may use a series of conversion factors based on available equivalencies using linking units. By strategically selecting the linking units, you can create conversion factors that allow you to cancel the given units and the linking units so that the result is in the desired units. Start with the given quantity. To convert from inches to yards, use two conversion factors. One conversion factor will convert inches to feet. The second conversion factor will convert feet to yards. Then perform the calculation. The result is in yards. Let's see a practical example where a unit conversion is needed. Then break the problem down to find important info, set up our conversion formula, and finally solve for the required units. An American car company has designed a new high fuel efficiency vehicle that is rated at 55 miles per gallon. The company plans to export the car to Europe and must advertise the fuel efficiency in SI units. What is the fuel usage rate in kilometers per liter? First, identify the information that you're given. In this example, you're given the fuel rating of 55 miles per gallon. Then identify the units in which the result should be reported. In this case, the results should be in kilometers per liter. Now decide what conversion factors are needed to convert the given information into the desired units. In this case, since gallons and liters are both volume measurements, we can convert between the two. An equation that represents the equivalency of gallons and liters is 1 liter equals 0.264 gallons. Since the gallons unit is in the denominator of the given quantity and we want gallons to cancel, we will place gallons in the numerator of the conversion factor. Gallons will cancel and leave liters in the denominator, which is what we need in the result. Next, since kilometers and miles are both length measurements, we need to convert the given miles to the desired kilometers. An equation that expresses the equivalency between miles and kilometers is 1 kilometer equals 0.621 miles. Since miles is in the numerator in the given quantity, and we want it to cancel, we'll place miles in the denominator of the conversion factor. Since we now have miles in a denominator and a numerator, we can cancel the mile units. When we perform the multiplication and division, we end up with 23.4 kilometers per liter. Because there are two significant digits in the original quantity, there should be two significant digits in the result. However, in the context of this problem, reporting the result in whole kilometers per liter would also be reasonable and probably the best level of precision for the purpose of the result, which is to advertise the fuel efficiency of the vehicle. Now you've seen how to set up a conversion factor to convert between units within a measurement system and between different measurement systems. Now try some practice problems to test your knowledge and come back to this lesson if you get stuck along the way. Before you know it, you'll be a unit converting machine. Good luck!